in this new example we have, it's different than our first example because there isn't a common factor between all three terms. You can factor 2 and 4 out of 4x squared, but you can't factor anything other than 1 or 13 out of 13x. So there isn't a common monomial factor that we can take out. So the process by which we're going to use to factor this is going to involve us making a lot of errors. You have to accept the fact that you're not going to get this right on your first try, potentially, maybe not on your second try, maybe not on your third try. It could take quite a few tries before we actually determine what are the factors of this trinomial. And what you have to understand is that's okay. By making all these mistakes, it'll actually end up making you faster at factoring. But you have to embrace the fact that you're not going to get this right the first, second, or third time when you try to factor this. And here is where the problem lies. Because this first term, this x squared term, has a factor of 4 with it, there's the possibility that the binomials could have x and 4x that multiply the first and first to get that 4x squared, or they could have 2x and 2x. It's one of them. It's not both. It's either going to be this one or it's going to be that one. It can't be both of them. But now, to further complicate things, to get a last term of 3, we need a 1 and a 3 in the last spots in both binomials. If we happen to put the 1 here and the 3 here, that's different than if we had the 4x, or the x and the 4x and the 3 here and the 1 there. Remember, we're trying to make this middle term, which comes from the outers times the outers and the inners times the inners. So if you look here, the outers times the outers make a 3x, and the inners times the inners make a 4x. And in this one, the outers and the inners make two different products. We'll have a 1x and a 12x. It's different. Now, if we use a 2x and a 2x, we could have a 1 and a 3, like that, which is the exact same thing if we had the 2x and the 2x and we had a 3 and a 1. Do you see the 2x with the 1 is the 2x with the 1 there, the 2x with the 3 is the same. So they're in essence the same thing because those two first terms happen to be the same. It doesn't matter where we put the 1 and the 3. But here again, we'll get different outer and inner terms. Our outer terms will make a 6x, our inner terms will make a 2x. We need our outers and inners to make a 13. Now what determines the way we organize it is based off of this plus, because just as before, that plus told us we were looking to make a sum that was the middle term. We are again trying to make a sum that makes a 13x. Now the way I go about figuring out what the binomials are is I don't write all this out. That's a lot of writing and it's completely unnecessary. So what I'm going to say to you is, just as before, when we wrote the factors of that last term, just like that, we're going to write the factors of this first term. Now, what multiplies to be 4x squared would be an x and a 4x, x times 4x, or 2x times 2x. Now, you can write the x's there with those factors. I typically don't. I typically just write them as 1 and 4 and 2 and 2. And I know there's an x there, and I just ignore it. And what I do is I try to make these outer and inner products up here with these. So what I do is I just arbitrarily start. I try a 1 times a 3 makes a 3. It's really a 3x, but I just write it as 3. And a 4 times a 1 makes a 4. Again, it's a 4x, but I just write the 3 and the 4. And then I see, what do I get when I add them? Because I'm trying to make a sum of 13. When I add those two, I get a 7. So that's in effect, if using the 1 and the 4 and the 1 and the 3 the way I did, that's this setup right here. There's your 3x and your 4x, 3x, 4x right there, which adds to be 7. So that's not the correct approach, because we're trying to make a sum of 13. So, remember I tried 1 and 3. Now I'll try 1 and 1. 1 and 1 makes 1. 4 and 3 is what's left over. 4 times 3 is 12. And then I add and see what I get. When I add 1 and 12, I get 13. That's what I was trying to get in the first place. So this is really a 1x and a 12x. So that's this setup right here. There's the 1x, there's the 12x, which makes our 13x. So once I arrive at that is what needs to be multiplied in the inner and outer loops, or products. I call them loops. I know they're really arcs, but I do often call them loops. What I do is I write my two binomials. I know I need a 1x and a 4x, so I write those in the first spots in both binomials. And now this 1x has to be multiplied by a 1. Here's the 1x. It has to be multiplied by a 1. And that's the outer product. And that 4x has to be multiplied by a 3. That 4x has to be multiplied by a 3. That's your inner product, your outers and your inners in FOIL. So there's your 12x, there's your 1x, which add to be 13. And the 1 times the 3 multiplies to be your last term of 3. Then I take care of the signs that go in between the two terms in the binomials. So I want them to add to be positive 13, so both of these need to be positive. So that tells me that they're both plus like that. Let's go to the second one.